Okay, here everyone, be quiet and don't get scattered and sit. How many times I should tell you? Come on, be in the front. This yellow color t-shirt. Come on the first bench. Yes, you can get shifted in the first bench. Any one of you. Good. Girls are following one rules. Okay. So, in the yesterday's class, I told you that we are going to take the exam, right? At the end of the month, in the month of January, the exam will be conducted. So, start preparing yourselves for the exam. Yes, and one more important news is there, that is we are beginning with the academy. I guess if anyone is there from this class for academy, you people have to start attending all the lectures from today onwards. Okay? So keep this in mind that today onwards academy is being started, and make sure that you are attending all the lectures. Whatever the rules and regulations are being put by madam on the group, you have to follow all those particular rules and regulations. Okay? Okay, so in the yesterday's class, we had learned about the Rutherford's atomic model, right? We will have a short revision of what we had learned in the last period. So here, we had learned about the three kinds of models who had defined the structure of atom. Right? तीन जनों ने structure को define किया atom के. Who are those three of them? Number one was Sir J.J. Thomson. Number two was Ernest Rutherford, and number three was Neil. Right? So I gave you the brief introduction of all the three concepts, right, for the structure of atom. I told you regarding J.J. Thomson, what J.J. Thomson said. J.J. Thomson said that the atom is a circular in a shape, and atom consists of a positive charges in the atom everywhere, right? But this model, what happened to this model? This model was discarded. Why it was discarded? Because it did not explain the stability of the atom, right? That is why this particular model was discarded by whom? This model was discarded by Rutherford. Okay. Then his model was called as the Plum and Pudding model. Plum and Pudding model. Okay, so this is very, very important, plum and pudding model. Many a times in the exam, they may ask you, explain about the plum and pudding model, or draw the diagram for the plum and pudding model. Okay, that can be asked for 1 mark in your BSA, very short answers. Okay, so in this case, you should remember the diagram, and then came the Rutherford, right? He worked on the drawback of J.J. Thomson. Right, he worked on the drawback of J.J. Thomson, and what he said that this particular model is not valid. Why it is not valid? If there is a positive charge, there will be also negative charge present in the system, right, to balance each other. So Rutherford came with an experiment, and that experiment was called as the alpha scattering experiment. Right? So I gave you the each and every detail about the alpha scattering experiment. What is alpha scattering experiment? In the alpha scattering experiment, he took a gold foil. Right? क्या-क्या चीजें ली थी उसने? Gold foil लिया था. And the thickness of the gold foil was 2.1 into 10 raised to minus 7 meter. Right? So this was the thickness of the gold foil. It is very, very thick. Then he took the scintillation screen. Scintillation screen. Right? What was the work of a scintillation screen? See, scintillation screen मतलब ऐसा screen है कि अगर कोई भी radiation या कोई भी alpha particle अगर जाके उस screen के ऊपर hit करेगा, it will show the fluorescent property. Fluorescent मतलब समझते हो ना? It will show the fluorescent kind of a property. That means वो चमकेगा. Immediately any kind of a particle hits on that screen, it will immediately show the lighting, right? And it will also show the dark spots on the screen. Now why the screen is used? Because by this screen we can understand whether radiations are getting passed or whether the radiations are getting absorbed by the gold foil. बराबर है ना? अगर देखो गोल्ड फॉइल अगर हमने ऐसा लगाया, यहां से हमने अल्फा पार्टिकल को इमिट कर दिया. If alpha particle, whether it is passing through it or whether it is getting absorbed into the gold foil. Are you understanding? Right? So he wanted to see whether this particular ray which was passing through the alpha particle, whether it was getting absorbed or it was getting totally transmitted. और उसको कैसे पता चला कि वो ट्रांसमिट हुआ है? उसने यहाँ पे एक सिंटिलेशन स्क्रीन लगाया, राइट? जो कि रेस पास हुए गोल्ड फॉइल से वो सिंटिलेशन स्क्रीन के ऊपर हिट हुआ, एंड एज सून एज इट गॉट हिटेड इट यूज्ड टू चमकता था, वो थोड़ा सा फ्लोरोसेंट के जैसा. रेडियम देखा है ना, रेडियम कैसे चमकता है, वैसे वो चमकता था, राइट? ही कंडक्टेड दिस एक्सपेरिमेंट इन अ डार्कनेस, and then every time when he saw that the alpha particle passed through the gold foil, it hit on this particular screen and it shown the lighting. Okay, and along with the lighting it also shown some of the other kind of dark spots. Now what does this dark spots tells you? This dark spots tells you that the radiation is being hitting on the screen. That means there is a lot of empty spaces around the atom. And atom has most of the mass in the center, in the nucleus. समझ में आ गया क्या? So this is what was conducted by the Rutherford. तो Rutherford ने क्या बोला? Rutherford ने बोला कि एटम का मॉडल कुछ ऐसा है. This is the model of the atom, right? Atom is not actually circular shape, but atom is a spherical in a shape. And he said that center we have a nucleus. And electrons are revolving around, and this nucleus contains the positive charge, that is the proton. बराबर है ना? इसमें दो तरह के सब एटॉमिक पार्टिकल्स है. नंबर वन पॉजिटिव चार्ज प्रोटॉन एंड न्यूट्रल पार्टिकल न्यूट्रॉन, राइट? एंड इलेक्ट्रॉन इज रिवॉल्विंग अराउंड. So this was the experiment conducted, and it was proved by the Rutherford that there is a lot of empty space remaining in the atom. Because experiment में भी ये prove हो गया था कि whenever the radiation passed through the gold foil, most of the radiations were easily passed through the gold foil. But what happened? Some of the radiations got deflected to certain angles, right? But whenever the radiation used to hit the positively charged nucleus, it used to come back again, or it used to get deflected back again. Why? Because we all know that alpha particle is a positively charged particle and our nucleus is also positive charged. तो positive का क्या होगा? Repulsion होगा. हमेशा याद रखो. Okay, so this was the case, and this is how he came to the conclusion for the model of the atom. Okay, then उसके बाद में इस Rutherford मॉडल को थोड़ा सा मॉडिफाई किया गया. It was not a drawback, it was a little bit of modification. Who did the modification? The modification was done by the Niels Bohr, right? So what happened? Niels Bohr said that the model given by the Rutherford is okay, right? But there are few things he would have considered. Now what are those few things would have been considered? उसने बोला कि अगर ये इलेक्ट्रॉन अगर घूम रहा है सिस्टम में, always remember any particular charged particle gets accelerated. अगर कोई भी ऑब्जेक्ट सर्कुलर पाथ में घूमेगा, it will get accelerated. And if the charged particle is getting accelerated, what will happen? It will radiate the energy, यानी कि वो एनर्जी लूज करेगा. अगर वो एनर्जी लूज करेगा तो क्या होगा? Ultimately the speed will become less, and if the speed is becoming less, the electron will become static. Static मतलब रुक जाएगा. Electron static हो गया तो क्या होगा? This electron will fall on the nucleus, and the atom will not exist. Right? So this was one of the drawback. So drawback was number one, he could not explain the stability of the atoms, and he could not explain the total number of electrons present in each orbit. यानी कि हर ऑर्बिट में कितने कितने इलेक्ट्रॉन्स होते हैं, he could not explain it through his Okay. Then next one was the Niels Bohr. Okay. So what did Niels Bohr did? Niels Bohr said that the atom suggested by the Rutherford is right, but he said that the electrons which are revolving, they are not revolving only in a one orbit, there are number of orbits present in the atom, right? उसके बाद में उसने कौन सा मॉडल दिया? Planetary model of atom, and this is the most famous model. Planetary model of atom, जिसमें उसने क्या बोला कि it is not necessary that the atom will be, electron will be only in a one orbit. Right? So this is called as the planetary model of the atom. He said that the electrons can be in any particular orbit. And who decides this? ये कैसे डिसाइड होता है? ये डिसाइड होता है based on the angular momentum of that orbit. I told you, whenever the angular momentum L is equal to nh by 2 pi. You remember? Yesterday I told you this formula. nh by 2 pi. What is n? N is nothing but the number of shells. How we can denote the number of shells? 1, 2, 3, 4 and so on. Okay. What is h? H is nothing but a Planck's constant. Planck's constant denoted by 6.626 into 10 raised to minus 34 Joule second. Okay. And then we have the value of pi, that is 3.14. Okay. So this is what is called as the angular momentum. Whenever the angular momentum is equal to nh by 2 pi for any particular orbit, then it is said that the electron will be present in that orbit. ऐसा क्यों? Because in that particular orbit where the angular momentum is equal to nh by 2 pi, it will not radiate the energy. यानी कि ये अपना energy lose नहीं करेगा. If it is not radiating the energy, if it is not losing the energy, what will happen? It will constantly move around the nucleus. Are you understanding this? This is very, very important. That is why this formula is also important. That is the angular momentum is equals to nh by 2 pi. So, for a different shells or for a different orbits, we have a different angular momentum, right? For example, for first shell, the angular momentum will be 1 into 6.626 into 10 raised to minus 34 divided by 2 into 3.14. Right? So this is the angular momentum of the first shell. दूसरे shell का क्या होगा? चलो बोलो जल्दी. 2 into 6.626 into 10 raised to minus 34. थर्ड shell का क्या होगा? 3 into fourth shell ka 4 into, right? So did you understand this? How to identify, how to write the angular momentum for each shell or how to calculate the angular momentum? Okay? Okay. Now, next point you all can put it down. Electrons have a same energy. Electrons have a same energy till they are in the same orbit. I give this point already. Okay. Then write down the next point. Point number 5. Okay, there is no point number 5. Next, write down types of orbits. Types of orbits or shell. Types of orbit or shell in an atom. Types of orbit or shell in an atom. चलो देख लेते हैं अभी टाइप्स ऑफ ऑर्बिट और शेल्स कितने कितने हैं. I'll keep this model as it is so that you people can understand easily, and I want every one of you to draw this because this is a very important concept. Everyone should draw this quickly. And give the heading Planetary Model of Atom. See, we will be requiring the 4 circles. 1, 2, 3, 4. हम लोग 4 जो cells है, important shells. That is K, L, M, N. Those shells we are going to learn. Okay. अरे एकदम असं प्रोफेशनली करायला जाऊ नका. ते घरी गेल्यानंतर करा. आता फक्त पेननी करा. अगदी कर्कटक घेऊनच करायला लागले सगळे. You made this circles. Okay, now you see the first shell. This is the nucleus. This is the nucleus. The first shell will be called as the K shell. First shell is called as the K shell, and the value of N will be equals to 1. Remember this. The second shell will be called as the L, KL. Right, and the value of N will be equals to 2. Third shell is called as the M, and the value of N will be equals to 3. And the fourth shell is called as the N, and the value of N will be equals to 4. So this is very important. Everyone should note down this. सबको ये पता होना चाहिए कि कौन से shells हैं, right? So K shell, L shell, M shell, and N shell. So there are total 4 shells present, and the value of N will be 1, 2, and 3 and 4. Okay. Then write down inner shells. Inner shells have a लोअर एनर्जी, यानी कि जो अंदर वाले शेल्स है उसका एनर्जी क्या है, सबसे लेस है. एंड द आउटर शेल हैज हायर एनर्जी. Did you all understand now? So this is our planetary model representation and the number of shells. ओके, जो अंदर वाला शेल है उसका क्या होगा, ये वाला अंदर वाला शेल है. दिस इज आवर इनर शेल, राइट. दिस विल हैव अ लोअर एनर्जी एंड दिस इज आवर आउटर शेल. सी, this is our outer shell, right? So outer shell has the higher energy, inner shell has the lower, right? मैंने कल एनर्जी का भी कंसेप्ट बताया था तुम लोगों को. Do you all remember about the energy concept? Whenever the electron wants to jump from a lower energy to higher energy, it will absorb the energy and go to a higher energy, right? Why it will absorb the energy? Because higher energy which is present, or the higher shell which is present, requires the more amount of energy. That is why electron should also gain that energy and go to a higher level. Okay, and if the electron wants to come from the higher energy or higher orbit to a lower orbit, he has to radiate the energy. Radiate मतलब energy lose करना पड़ेगा. Did you understand this? So this is very important. Everyone should know this. Okay. Write down next point. Yes.
Sir, from where the atom will gain energy?
The atoms are gaining the energy.
No, sir, the electrons.
Electrons.
Which comes from first shell to the last compound.
Actually, there is a one concept that is called as the photons, right? Quanta are photons, and from that photons they gain the energy, right? Okay, I'll give you the detailed explanation in tomorrow's class. For this particular concept, we have to learn the Planck's quantum theory. Planck's quantum theory से हमको पता चलेगा कि how the electrons are gaining the energy, right? Okay, but before that, write down now. These shells can be further divided into subshells. These shells can be further divided into subshells. Yes, write down subshells. S subshell, P subshell, S subshell, P subshell, D subshell, F subshell, and G subshell. And G subshell. Right? So these are the subshells. Subshells are also called as, note it down. Subshells are also called as orbitals. Subshells are also called as orbitals. Okay? तो कितने सारे हमारे पास subshells हैं? Shells कितने हैं? How many number of shells are there? 4 shells are there. K, L, M, N. How many number of subshells are present? 5 subshells are there. S, P, D, F, and G subshell. Okay. We rarely use a G subshell, but at least up to F subshell we use the particular इलेक्ट्रॉन फिलिंग. ओके, और वो इलेक्ट्रॉन फिलिंग कैसा होता है उसके लिए एक प्रिंसिपल है, दैट इज कॉल्ड एज द अबाउस प्रिंसिपल.